A silver humanoid walks across a white lab floor. A moment later, its fingers close around an apple. This is not a consumer helper robot. It is a research platform. NVIDIA calls it the Isaac GR00T reference humanoid robot, and Unitree is presenting the hardware as H2 Plus. The point is the stack. NVIDIA is giving robotics teams a ready starting point: a human-size Unitree body, tactile Sharpa Wave hands, Jetson Thor onboard compute, and the Isaac GR00T software workflow around it. Humanoid research usually starts with months of setup. Teams have to connect the robot, sensors, teleoperation, simulation, training data, model evaluation, and deployment before they can test a useful skill. GR00T is NVIDIA's attempt to shorten that setup. A researcher can capture a human demonstration, recreate it in simulation, generate more training examples, test the policy, and push it back onto the robot through Isaac ROS. The body is Unitree's H2 Plus. It is nearly 6 feet tall, about 150 pounds with its battery, and uses 31 body degrees of freedom for human-scale walking, reaching, and upper body experiments. The hands are where the story gets more specific. Sharpa Wave gives the platform 2 5-finger tactile hands, with 22 active degrees of freedom per hand, and more than 1,000 tactile pixels in each fingertip. That matters because useful humanoids need more than a good walk cycle. They need to hold tools, rotate objects, feel contact, and recover when a grasp is slightly off. The computer inside the reference design is Jetson Thor T5000. NVIDIA says it pairs a Blackwell GPU with 128 gigabytes of unified memory and up to 2070 FP4 sparse teraflops for real-time robot inference. That compute is there because the robot has to process cameras, body state, hand contact, speech or audio, and model outputs while it is moving in the real world. The demo footage also shows the limitation. In the Apple and tool shots, a person in a VR headset is guiding the robot. The reference design is a way to collect data and train skills, not a claim that every task is already fully autonomous. NVIDIA says early users include research groups such as AI2, ETH Zurich, Stanford Robotics Center, and UC San Diego's Advanced Robotics and Controls Laboratory. The robot is expected to be available from Unitree in late 2026. The bigger story is a platform race. Unitree supplies the body, Sharpa supplies touch, NVIDIA supplies the compute and software, and labs get a common machine to compare ideas on. If this works, the boring part of humanoid robotics gets shorter. Researchers spend less time wiring the stack together and more time asking the hard question: what should a general-purpose robot actually be able to do?